Start Bay has four beaches inside it, and they're all shingle beaches or gravel beaches. The biggest one of them is Slapton Sands, an uninterrupted 4.5 kilometre long shingle barrier, quite high, with a unique freshwater lake behind it. And what is so interesting from a sort of coastal geomorphological point of view is that the beach is subjected to two different types of wave directions. So depending on where the waves are coming from, large amounts of gravel are moved either from south to north or from north to south. And in the long run, in the really long run, it's sort of a balance between these two directions. But we seem to have entered the phase with a lot more southerlies than easterlies. So we've seen the progressive depletion of gravel from the southern part of the bay, the southern part of Slapton Sands, all the way to the northern part of the beach. And so we had an unusual set of storms in January, named storms, Goretti, Ingrid and Chandra. They were all from the south. They took a lot of sand and gravel away from the front of Torcross. They lowered the beach levels by probably about 2 meters, maybe even more. And then we had an easterly storm, not an extreme storm, but from a completely different direction that hit Torcross full on, arriving at these lower beach levels, and it completely destroyed a section of road. We've been there before. 2001 was the first time, and 250-meter section of road was taken out from somewhere else, not the same location. Then we had a 2013 and 14 and the 2016 winter were really bad in terms of beach erosion. A lot of damage done to the seawall at Torcross, also lowering beach levels and also road damage. Then we had a 2018 storm called Storm Emma, which was at the back of the beast from the east, a really cold period. Again, a huge section of road got damaged. We've done a large number of different types of field experiments, from measuring waves running up and down the beaches to monitoring the impact of an extreme storm event and deploying current meters and wave sensors, and also doing monthly monitoring along the whole of Slapton Sands since 2005. So Slapton Sands is one of very few locations in the world where we have a really long-term time series of beach volumes and beach change at a monthly resolution. So we're looking at almost like more than 200 surveys already. As a result, we sort of know exactly when and where the sand and the gravel is moving to. And then by linking it to the wave conditions that are measured routinely by a directional wave buoy, we can start to put the two and two together and try to understand and explain the changes that we're observing. The backdrop against all of this is a slowly rising sea level. In the southwest of England, we've seen a rise in sea level of about a foot, about 30 centimeters in the last 110 years. Sea level is rising at 3 to 4 millimeters per year at the moment. Now, very difficult to observe over 10, 20 years. That's only a couple of centimeters, but it all adds up. And 30 centimeters in 100 years is actually quite a lot, because it makes the difference between a spring tide and an extra high spring tide, or the difference between an extra high spring tide and an extra high spring tide with the storm surge on top of it. As I explained, what's happened last month is not a one-off, it's happened before, and accept that it's going to happen increasingly frequent in the future. So in the long run, it's not sustainable to have infrastructure like a road, like houses, car parks, holiday parks on top of dynamic sandy or shingle ridges. So it's not sustainable. So the only way that can be maintained is by increasingly defending. And when the defenses are no longer up to scratch, you need to keep investing in them, making them higher or making them wider. That's started to become unsustainably expensive, and decisions will have to be made for different locations on the UK coastline, not just Slapton, whether we're going to continue to protect or whether we slowly start to retreat from the coastline.